Hello everyone, welcome to our channel Online Classroom. In the previous lecture, we discussed the basic ideas of matrices, basically the introduction portion. In this lecture, we will discuss the topic matrix addition, subtraction and multiplication. Okay, so let's start the corresponding topic one by one. Look, first topic is matrix addition. Well, in this category, suppose A and B, these two are matrices. Okay, now we have to check the order of the corresponding matrix A and B. If the order of the corresponding matrix A and B are same, then we can add them. So this is the first restriction. Okay, if the orders are same, then we can add them and we can get the final value as C. That is the new matrix. Okay, so let us check some examples with this matrix addition rule. Look, this is one of the square matrix 2 by 2 and this is another matrix, basically it is 3 cross 2. So look, the orders are not same. So we can say that we can't add those two matrices. So that is the first conclusion. Now focus on this example. Basically this is square matrix 2 by 2 and this is another square matrix 2 by 2. So obviously the orders are same, so we can easily add them. Okay, the question will arise, what is the evaluation value? Look, this is the first matrix 2 by 2 matrix and this is another matrix 2 by 2, so we can add them. Now we are focused on the elements. This is 3, so first element will be 3 plus 1, that is your 4. Next one 4 plus 5, that is 9. Next one 2 plus 3, that is 5, and 1 plus 7, that is your 8. So that is the final computation, or we can say that this is the final matrix. Now look, we perform the corresponding matrix addition in case of square matrix. Now what will be the addition in case of rectangular matrix? So we will focus on this example. Basically A, this is a matrix having 4 rows and 3 columns, and B, another matrix having 4 rows and 3 columns. So we can add them. So in this case, obviously the final matrix becomes element wise addition. That means 5 plus of minus 3, this is the first element. Second one minus 5 plus of minus 4, and last one 3 plus 0, that is your corresponding element. Okay, so we compute the first row. Similarly, we can easily perform the next rows, like second one, this is third one, and this is your fourth one. Okay, so if you simplify it, ultimately we get the result as 2 minus 9 3, that is your first row. Second one minus 2 6 6, third one is minus 6 minus 1 3, and last one 0 minus 5 0. So that is the complete idea of matrix addition. And look, after the addition, the generated matrix order is same as A and B. Okay, so let's focus on the next topic, that is your matrix subtraction. Well, in case of matrix subtraction, basically restriction is same, that is we have to check the order of A and B. If these two orders are same, then we can easily subtract them, but otherwise we can't subtract it. Okay, so look, this example, this is 2 by 2 matrix. Basically this is 3 cross 2 matrix. So obviously orders are different, so we can't subtract them. But here look, this is 2 by 2, another this is 2 by 2. So obviously we can subtract it. So this is the corresponding subtraction rule. Now obviously we need to know how we can subtract the corresponding matrices. Look, this is your A, this is your B. Element wise subtraction, that means 1 minus 1 0. Next one 2 minus 3 minus 1. Next one 3 minus 5 minus 2. And next one 4 minus 5, that is your minus 1. So we get the corresponding final matrix. Okay, and look, the order is still 2 cross 2. Now we are focusing on rectangular matrix subtraction. This is one of the rectangular matrix 3 cross 2. And this is another rectangular matrix, basically 3 cross 2. So if we want to subtract it, obviously corresponding orders are same, so we can easily subtract it. Obviously the members will be 3 minus minus 2, that is the first member, 2 minus of 5. This is the corresponding second one. Next one, 1 minus of minus 8. This one is 4 minus 12, and so on. So obviously, if you simplify the corresponding matrix, we get the result 5 minus 3, 9 minus 8, 5, 21. So that is the complete idea of matrix subtraction. Well, now we are focusing on very important topic, that is matrix of multiplication. Look, if two matrices are given like A and B, if we want to multiply those two matrices A and B, the final matrix become AB. Okay, but there is a restriction. Basically, the column of A that should be equal to the row number of B. That is the first restriction. That means column of the first matrix must be equal to the row of the second matrix. So that is the restriction in case of matrix multiplication. Okay, otherwise we can't multiply it. Look, this is one of the example. Basically, if I consider A as this matrix and this is your B matrix, this is basically 2 by 2, this is basically 3 cross 2. Okay, so that means the column number is 2 here and the corresponding row number is 3 here, unmatched. So we can't perform the product AB, right? Now we are focusing on this matrix. Look, it is a 3 cross 2 matrix. That means the column number is 2. Okay, and this is 2 cross 3 matrix where the row number is 2. Look, these are same. That means we can easily multiply them. Well, after multiplication, the final matrix will be of order 3 cross 3 because this portion actually cancel out. So the new matrix becomes 3 cross 3 order. Okay, so let's check some of the example and the evaluation process. Look, this is your matrix 1, this is your matrix 2. Both the matrices are of 2 cross 2 order. Okay, so if I want to multiply it, we have to focus on the first row. Look, the first row that will be multiplied with first column. That means 3 into 1, 3 plus 4 into 3, that is your 12. So that is the first member. Second one will be first row versus second column. That means 3 into 5, that is 15, plus 4 into 7, that is your 28. Well, now we are focusing on the next row, that is your second row versus first column. That means 2 into 1, 2, plus 1 into 3, that is your 3. So that is the corresponding member. Next one will be second row versus second column. That means 2 into 5, that is your 10, and 1 into 7, that is your 7. That's obviously the corresponding member. So if you simplify it, we get the result as 15, 43, 5, 17. So that is the matrix multiplication rule for square matrix basically. Now if it is rectangular, look here we can observe that this is one of the rectangular matrix of order 2 cross 3. That means the number of column is 3. But here the number of row is 3 and column is 2. So the corresponding column number actually matched with row number. So we can easily multiply it. Now look, if you consider this particular first row, it will be multiplied with first column. So it will be 1 into 10 plus 2 into 20 plus 3 into 30. So that is your first member. And next one will be first row versus second column. That means 1 into 11 plus 2 into 21 plus 3 into 31. So that is the corresponding member. And if we focus on the second row versus first column, that means 4 into 10 plus 5 into 20 plus 6 into 30. So that is the corresponding member. And last one will be obviously second row versus second column. So 4 into 11 plus 5 into 21 plus 6 into 31. Look, the corresponding order of the matrix is 2 by 2. And if you simplify it, you get the corresponding result as 140, 146, 320 and 335. So that is the main idea of matrix multiplication, and you can apply this particular idea in any kind of example. Well, in the next video, we will focus on the inverse of a matrix and also adjoint, cofactor and minor concepts of matrix. So stay tuned with us. Thanks for listening us.